Okay, this is from the mock exam, the free response question number 4. So they gave you a table and a whole bunch of information, but part A is just asking for a midpoint Riemann sum, so we're just going to start there. So it said you need 3 sub-intervals of equal length. So the only way you're going to be able to get that from the table is to set it up with these intervals shown. Okay, and this is going to approximate the value of f of 6. Okay, so if we want a midpoint, first we're going to need the length. So for this one it's 2, for this one it's 2, and for this one it's 2, which it should be because it said they're of equal length. Okay, now we just need the midpoint. So the midpoint between 0 and 2 will be 1. So you're going to look at your table, and when x is 1, you will get 3.5. Okay, the midpoint between 2 and 4 is 3, so you look at your chart and you get 0.8. And the midpoint between 4 and 6 is 5, so you look at the chart and you get 5.8. Okay, so you're going to multiply these and get these values. And you're going to add those together and you're going to get 20.2. And getting this answer of 20.2, that was equal to 1 point. Okay, but it's now saying use this Riemann sum to approximate the value of f of 6. So the graph that they gave you, the table they gave you, was for f prime. So you want to figure out where were you when x was 6. Okay, so where were you? Well, it's the distance that you traveled from 0 to 6 of f prime dx. Okay, so because f prime, when you do the antiderivative, will get you back to f, so that's what we're looking for. All right, so you do the antiderivative, and you're going to get f of x as it goes from 0 to 6. So you're going to get f of 6 minus f of 0. Okay? What am we doing? Okay, so we're doing f of... Okay, now here's the thing. And I keep mentioning this over and over. You need to know, if you want to go from 0 to 6, you need to know where were you at 0. This is like that question we had with like oil or water or something in a barrel, and you need to know like how much you had at the beginning. So if you read in the story, it says the function satisfies f of 0 equals 20. So that means at time when x equals 0, f of x was equal to 20. So you're going to have to add 20 to this. So we're going to have a 20 plus, and now we're going to have the f of 6 minus f of 0. Okay, so just for your point values, let me just stop for a minute. If you did this, that got you 1 point. Okay, so we have f of 0 is 20, that's where we started. Okay, now we have to do this. So what is f of 6? You're going to look at your graph, and you're going to get 7 minus sorry, that's wrong. I'm looking at the table. I'm looking at like 10 different papers here, so I don't screw you guys up, and that's all I'm doing. I can't use my graph for f of 6 because that's f prime and we need f6. So we have no way of getting that. So this is when you have to kind of step back and say, okay, I must have missed something. And the thing is, to go from 0 to 6 of f prime of x dx, didn't we just estimate that and get, whoops, and get this? Right, that's what we were supposed to do. We were supposed to use a midpoint Riemann sum to approximate f of 6. And we got 20.2. So f of 6 is this piece right here. So we didn't even need this. Okay, we got 20.2 is just an estimate. So 20 is where we started, 20.2 is our estimate, and that's going to give us 40.2. And that gives you 1 point. So altogether, this was worth 3 points. You got 1 point for this, you got 1 point for setting this up, and then you got 1 point for this. So that wasn't so bad. Okay, now we're going to move on to B. Okay, here's part B, and B is, I think, pretty tricky. So the question is, can f of 6 ever be equal to 70? That would be the question. Okay, so, because remember, we just did an estimate before. So this is how I thought of it. You may have a different way to do this, but I thought of what does the f prime graph look like? So I know I'm using the table. So at 0, I'm at 4. At 1, I'm at 3.5. And if I keep graphing this, I'm going to get something that looks like this. And it's going to start going back up. So this is at 4. And then at 5, I'm here. And then at 6, I'm here. Okay, so when I'm at 6, y equals 7. Okay, so when x equals, this is how I thought of it. When x equals, okay, the slope is 7. Let me just take that away. Sorry. Okay, so when x equals 6, the slope equals 7. This is what I thought. So if it started over here at 4, and it was a constant slope of 7, which we know it's not because it's a curve, but if it was, because that's the biggest it could be, then for each increment going from 0 to 6, each piece, the biggest would be is 7. So 6 times 7 is 42. So that would be the biggest that it could possibly get. So you would write from 0 to 6 of f prime of x must be less than or equal to 42. Okay, but they're not asking for the whole integral, they're just asking for this. Okay, so remember earlier we said that from 0 to 6 of f prime of x, if you took the antiderivative and you substituted in, you'd get f of 6 minus f of 0 must be less than or equal to 42. But we were told that f of 0 was 20, so we would get f of 6 minus 20 must be less than or equal to 42. Okay, I'm going to go over here. Okay, if I add 20 to both sides, I'm going to get f of 6 must be less than or equal to 62. So that's what the question was. Could f of 6 ever be 70? But we just discovered that f of 6 must be less than or equal to 62. So the answer is no. F of 6 can never equal 70. So let me give you the point values, and then I'm just going to kind of go over that again. So if you, let's see, if you wrote this, that was a point. And then if you got the answer because of this, that's one more point. So that's 2 points for a lot of work. Okay, so this is, I just want to go back in case I wasn't too clear. Let me get another color. Okay, so let's just say that this was a straight line that went like this. If this is at 4 and I'm a slope of 7, I would go up 4 over 1. I mean, it's not lining up with my picture here, but that would be the point 1, 11. And then I go up 4, I'm sorry, up 7 and over, and up 7 and over. So every time I'm going up 7, I'm going to do that 6 times. So 7 times 6 is 42. So the highest my y value would ever get is 42. Okay, so that was part B. Okay, part C, thankfully, is pretty simple, I think, and it's worth 3 points. And it has nothing, I'm sorry, it's worth 2 points. And it has nothing to do with the other questions, so even if you're going to do the other parts, you could still do this. All right, so you take the antiderivative of f double prime of x. The antiderivative is f prime of x as it goes from 2 to 4. So first you're going to put in the 4, and then you're going to put in the 2. But you have the graph of this. So f prime of 4 is equal to 1.7, and f prime of 2 is equal to 2. So 1.7 minus 2 is equal to a negative 0.3. So the point values were, if you did this, you got 1 point, and if you got the final answer, you got 1 point. That was like really fast, and that one was pretty simple. Okay, and finally part D. we have a limit problem using that f of x, and so the first thing we always want to try is substitution. So we're going to substitute in 0 wherever we see an x. And we will get that. And f of 0 we knew was 20 from before, minus 20 times e to the, anything to the 0 is always 1. We get 0.5, f of 0 again, that was going to be 20, minus 10. So we're going to get 0 over 0, and that means that we can use L'Hopital's rule. And if you just wrote L'Hopital's rule is being used, you got 1 point. Okay, so that's pretty good. All right, so now that we wrote that we are going to use L'Hopital's rule, we obviously would not erase that on our answer sheet. We're now going to take the derivative of the numerator. So the derivative of f of x will just be f prime of x. And then you're going to get 20, and the derivative of e to the x is just e to the x. Remember, this is not a quotient rule. You do the numerator and denominator separately. So for the denominator, you're going to get 0.5. The derivative of f of x is f prime of x, and the derivative of negative 10 is just going to be 0. So let's try to substitute now and see if that will work, or we need L'Hopital's rule again. So we'll get f prime of 0 minus 20 times e to the 0 over 0.5 times f prime of 0. Okay, f prime of 0 is equal to 4 minus 20, because e to the 0 is just 1, over 0.5 times f prime of 0, which is 4 again. This gives us a negative 16 over 2, so no problems about having any zeros in the denominator, and that gives us negative 8. So the point values were 1 point for saying that it was L'Hopital's rule, and then 1 point for getting the answer, and that finishes question number 4.